Today we're going to be going over deploying an ERC1155 NFT to Polygon zkEVM testnet. Now this is my ultimate guide to be able to create this amazing Mythic Card Collection, and you can see the entire walkthrough on my Medium post, which will go through this entire process that we're going to be doing in video format today. One of the main tools we'll be using today is Midjourney to be able to create the design assets. If you're unfamiliar with Midjourney, it's a great tool to be able to generate artwork with basic prompts and essentially create the design assets that we need for our card collection. The other tool we're going to use is ChatGPT, but not in the sense of being able to design any prompts or do any design work in that sense. We'll basically be using it for creating a story behind the cards. So that way I'm not too creative. I don't have to be too creative in terms of the naming conventions or creating some descriptions for these particular assets. So here I'm going to open up Midjourney on Discord. And this is the main way that you can use Midjourney, is to send it prompts. And you can see some of the design assets that I had previously generated for this particular walkthrough. And what I'm going to do is try to mimic this and show you the process of how I kind of got to this. The main inspiration I'm using for these cards is by this game from Blizzard called Hearthstone, which has these cards and this style done that I really, really like. And what I'm going to do is leverage that design look for these cards. So the first prompt I'm going to make is for just an item, let's say a sword, in the style of Blizzard Hearthstone, the game essentially. Now you'll notice that this first iteration is not going to be the greatest, and we're going to try to adapt it to get it to where we want it, where it's just the item, and then we can go from there and create the design assets. So this is the first iteration. It's not bad itself. There's obviously some wonkiness going on in terms of the blades, but overall it looks pretty good. And this bottom right one is probably the one that I really, really want to generate. Now, one thing I can do to take it a step further is to try to remove some of the items in terms of the backgrounds to get it to be more specific as to what I want, and maybe even adjust the aspect ratio, which I didn't do before, to be able to get it in that card format essentially. So let's adjust our prompt to be able to say, hey, we want just the item itself, no other frills or decorative details, just the item on a sole background and an aspect ratio of 9:16, where it's, almost like 1080p to 1920, so it's vertical essentially. So my second prompt is a sword, just the item, with no characters in the photo and without any other items, in the style of Blizzard Hearthstone game, with an aspect ratio of 9:16. So this is our second iteration. We'll notice that the sword is by itself. This is pretty good, but you'll notice that there's some other items within the photo itself. So we can try to clean this up a little bit by just being more specific in our prompt as well. So let's do a third prompt this time, just being able to be more specific and saying that there's no other items within it. So this is our third iteration. You can see that Midjourney is having a little bit of an issue just showing one item, but we can say that maybe the bottom left is a pretty decent version for us to kind of work with. So from there, I would just go upscale to upscale version 3, or the third iteration here, and it'll upscale that image in terms of the larger file that I'll need to use for my assets. Now, while we're waiting for this prompt, I'm going to give it another prompt for the decorations that we're going to have around the card. So to make it consistent, and essentially I want to be able to have a template of what it looks like surrounding each card, so that there is a sense of it belonging to a set or a series in that collection. So the prompt I'm going to use is a decorative rock background that takes up the entire photo with no characters in the photo, just the item itself, and without any other items, in the style of Blizzard Hearthstone game. Now, again, what I'm trying to do here is take the decorations. It won't be perfect, but it'll be the border that I'm going to be using for around the cards. And you can see we have the fourth iteration of the sword, which is great. So I'm able to open this and just download this in our assets to use later. For the rock background, looking at these, I would say the one that the most is usable is probably the top left. I'm not too concerned about the heart that's inside there. I'm just going to be able to cut it out in terms of Photoshop by using like one of the lasso tools, and then use that to be able to just establish or follow the lines of the rock to essentially frame those cards of those items. So if I upscale that version, I'll take it, and then from there I'll be able to use it in Photoshop. While we're waiting for the rock background to kind of upscale, I'm going to give it another prompt. This time it's for a decorative background. Now, I don't want it to be rock this time. I want it to be a wood, which we've typically seen on some of the other cards from the Blizzard Hearthstone series. So I'm going to give it a decorative wooded background with no characters in the photo and just the item itself without any other items facing forward in the style of Blizzard Hearthstone game. So now we have the decorative aspect that will be surrounding or framing the cards of the items. And the other item we have is the back of the card that we're going to give in terms of a heart. In that sense, I think probably for me is the bottom left or the bottom right is the nicest. So we'll use something like that. Now I'm just illustrating the idea of using Midjourney, and we're going to be using the graphics that I had previously generated and showing you just the prompts of what I went through to be able to create these graphics. So in the same process, I would just upscale, number 3, and then take that graphic to be able to bring it into Photoshop. So these are the graphics that I got generated from Midjourney. This was an axe, we got a sword, we have a skull, and we have some sort of heart thing. And you'll notice that I tried my hardest to be able to say, hey, can you create a bow, like a bow and arrow? But it kept thinking as a bow that you just tie over a present. So I kept sending it prompts and giving it bow archery, but it kept coming up with these weird aspects of a heart. So I just went with this and said, okay, I'm going to come up with a story in that sense with it. This was the graphic that I got for the rock formation, the decorating framing aspect for the cards. And here's the back that I got for the cards to be able to kind of create some sort of decoration for it. So these are all the original assets. And again, you can find all these graphics in the GitHub repository to see what these look like. Now, what I did in Photoshop is I created a basic square to kind of start off with. I know that it's going to be rectangular in terms of vertical for the cards. So I started off with basically just the items as squares. And this is prior to me learning about the aspect ratio, which I could have taken advantage of. But here what I did is I took the original image, I duplicated it, kind of stretched out the background a little bit more so it kind of makes it more consistent so I can fill up more of the space. I added some sort of gradient to be able to say, hey, at least it's coming down a little bit. And you'll see as I played around with it, what that actually looks like. I took the card again, duplicated it one more time. And then what I did is apply a mask to it. And that mask kind of just faded out the edges so it's not as apparent. And what I did here is I adjusted this also while I had the decoration around it. So this was a first base and this was just getting at the final aspect of it. Once I had that, essentially I took the original image that I had, which was basically the rock itself. From there, and let me just disable this glow. So what I did is take the rock itself, just paste it right there, and then played around with different versions of it where I pasted it out so that I got the full edges, more on the side, really just wraps around, getting the full aspect. And you'll notice I'm applying these masks to it to be able to just get at specific points of the rock, of the formation. And you can see this is the final version of where the rock is. And you're thinking, okay, well, what is this? This doesn't really look that much. But if we took the vertical aspect, this is what the card might look like. And then what I did from there is apply a mask, which essentially followed the lines of this rock to kind of establish some sort of formation around it, and then establish the consistency of what that decoration might look like. From there, you can see what that application looks like, where it's applied, and you can see now that the item is apparent and it's decorated. It's got that decorative framing of the actual item itself. And the last little bit is I added some glowing aspects to it. So what I did is I applied some purple to it, which was an overlay, and then I applied some orange to that little stone in the bottom right to keep it kind of consistent. And this process I followed over and over again for all the other items. So I got the heart here, and I got the proper glow for it. And then what I have is for the axe, and then I have the proper glow for the axe. And then from there, from the skull, which I'm calling a skull scepter in this case, and I followed it and added that glow to it. So following that same principle of creating all these cards and then saving them out as their specific format. The last thing I did with this is also establish the back. So I'll notice all I did was stretch out the graphic that I had, make it fit within a vertical layout, and there I had my backing for the cards. So looking at the format of the cards, we have here the back, we have the axe, we have the heart, or I'm calling the paladin's fiery heart, the scepter in terms of the skull scepter, and we have the sword for all the items that we've presented, and we got them in the format that we wanted. So again, everything was generated in Midjourney. All I did was add specific shadows and cut things out. Just did a little bit of photoshopping in terms of getting into the format that I need. But these are the final formats of the card to be able to animate that going forward. One small note is that I did create smaller versions of each one of the graphics as 480 by 640. And this is to be able to save on space, so it doesn't make it crazy to be able to load these cards, and we can get them to the format that we really need to, and still visible with a decent quality on-chain versus, hey, having to download a very, very large file. So here in our project folder, we'll see that there's an assets folder with all the assets from the cards so that we can use and create the animations from. So in our SVG folder, I'm going to create a sword.svg, and this will be the file that we're going to be working on to be able to create the animation and ultimately get at the rotation. So within this sword.svg, I'm going to paste the code that I had originally to kind of get at the first iteration, and we can kind of see what that looks like. Now I've scaled this down from 512, which I ultimately want to get it at as the format, to 256 by 256. Now, what you'll notice is that there's two elements here. Or three in that sense. One rectangle, which is just the red card itself, which is just one card that's rotating back and forth. And then the white, essentially, to be able to fill the actual canvas of what that is to kind of hold the entire card. Now, what you'll notice is I positioned it in a specific direction. And there's something about SVGs that need to be considered. In CSS animations, you can use a property called backface transparent or hidden. So when the card flips to its backside, it won't show anything. Unfortunately, in SVGs, is not fully supported because it actually it's almost like Z indexes where it just like layers it on top of each other and takes priority. So in order to take advantage of this, what you'll notice is I'm switching back and forth from an animation where it gets to half a point where it's going almost semi-transparent, so that when it's getting to its side and it's fully rotated, it's kind of disappearing. And what my goal is to try to get, hey, if this is disappearing at this point, then I can take the back and start making it appear in terms of a transition, so I can switch back and forth in terms of invisible, visible, hidden, visible, etc., and going back and forth. And what you'll notice here in the front ID is that the width is set. It's a block. We're just setting the rotation to rotate in terms of the y-axis. And we're just applying the animation of rotate front from a point, and this is important, the transform origin, which is essentially the middle of the actual document, so that it knows where it should rotate from, because this is a big factor. So this is the second iteration. The only difference here is that we're now adding another rectangle, which will be the back, and it follows a different rotation where it has a different starting point as to where it's going to rotate from. Its background is blue in that sense, and it's just going to be slightly different. You'll see that applied here. The fill is set to blue and the front is set to red. And what this is going to do is saying, hey, it's going to rotate also on its y-axis, but its default state as its starting state is going to be to minus 90 degrees. So if I save this, you should see that the opacity switches between 1 and 0 when the cards get to their side edge, and then it switches back and forth. So if I save this, refresh it, we'll see that the card is rotating red, and then the back shows as blue, and it switches back and forth between those animations. So this is great. So we've achieved this idea, or at least this trickery of saying, hey, it looks like it's rotating from a back to a front, or a front to a back, but we're doing this just by hiding and showing certain elements. So what we're going to do here is use a service called Base64 Guru. What it's going to do is we're going to upload an image to it, and it's going to convert it to Base64 encoding. And with that, we can actually embed that in the SVG directly as an image tag. So here I've selected the card back. I'm going to encode it, and it's going to create that Base64 for me. Now what I'm going to do is do this both for the front and the back of the cards to be able to kind of get the animation, or get the graphics within that animation. So this is our third iteration. We're going to be showing the graphic of a heart instead of a sword, but we'll replace this afterwards. You'll notice everything stays the same. The rotations are all the same. The only difference here now is that instead of rectangular tags, I'm using image tags with a href of data image JPEG. So essentially the MIME type, then Base64 comma, and this is whatever the Base64 data that we got back that's pasted here. What that does is convert that image so that it can be displayed directly within that SVG. So if we save it, we should see it rotating back and forth between the front and the back. So here we have the graphic of the front, and as we're switching, we see the back of the card to get that full rotation. For our fourth iteration, we're just going to clean up in terms of getting the class for card set up so that it applies to both front and back, because we don't need the same attributes applied in different IDs. And then what we're going to do is we're going to take advantage of something called gradient, radial gradient. And what this is going to do is basically create a radial gradient of orange so that it matches the color of the actual heart. So when I save this and apply it, we should see that that gradient's applied fully. And we've also applied a drop shadow to the image itself, so it looks a little bit nicer. The last step to this is to be able to add a border radius. So I want the cards to be a little bit more rounded, and this is a personal preference. The unfortunate part is that you can't use border radius as a style, as a CSS styling applied to these. So what you're going to have to do is apply something called a clip path, which essentially is almost like a mask. And what this is going to do is match the size of the card with the difference of saying, I'm going to apply a radius of on the X and Y degrees of 12 pixels essentially. And what this does is I'm saying, hey, this is the ID of clip. And what I want is the clip path to follow the URL of clip, which is that ID. So once I save it, refresh it, we'll see that the cards now have a rounded look to them, and there's still a little bit of a drop shadow that's lost, but you get to see the gradient also behind it, getting at the final look that we're essentially aiming for. So now that I have 4 SVGs set up for each one of these graphics, the next thing I want to do is be able to upload this to some sort of permanent storage. And the storage we're going to be using is Arweave with Bundler to easily upload it to a permanent storage solution. Now for that, I'm going to have to init the project to have a package.json. I'm going to install .env, bundler network in terms of the client. I'm going to take advantage of this other library called Big Number, which we'll use to be able to do the conversion for some of the funding of the network itself to be able to upload it. So because it's in order to be able to upload the files, we need to be able to fund the node to be able to do that. The next thing is also install all the types. So take advantage of TS node, TypeScript, and then I'm going to initiate TypeScript to be able to get the TS config, make an upload folder, and create a .env environment variable file. Now that I have everything installed, one of the things I need to do is set up my environment variable to be able to put my wallet private key. Now it's important that the wallet that I use here is a wallet that actually has mainnet Polygon Matic in it to be able to pay for the node to upload the files. So here I have my account, I have some Matic in it, and what I'm going to need to do is get the private key from it. So I'm going to export my private key, copy that value, paste that into my wallet.env file, and then we should be good to go in terms of trying to set up the script to upload these files to Arweave. So next I have a upload folder. What I'm going to do is create a new file called Arweave files.ts. And what I'm going to do is paste an entire script in here and go over what is happening. So I'm going to be using the Bundler client. So Bundler is an easy way to be able to upload to Arweave with like other tokens, essentially bundles the transactions to make it a lot easier and cheaper as opposed to trying to do it directly with Arweave. I'm going to take advantage of the file system to be able to reference the actual files here and the path, and then load in my .env file, which I'm going to take advantage from the wallet credentials that I just posted, and then Big Number, which we'll look at in terms of doing some conversion as to what that looks like. So if we go a little bit further, we'll see that I set up some constants here. I am referencing a specific node. There's actually, I think, 2 or 3 different bundler networks. You'll notice that the payment method is Matic, and I'm passing over my private key from my wallet. Next, we'll see I'm going to get my current balance. So basically, this is going to say, hey, how much tokens do you have funded on this specific node? And then convert that to an actual value that I can actually see as opposed to a big number. So I'm just going to output, hey, from reference sake, because sometimes it's good to know if you have enough tokens to be able to fund things. Sometimes uploading things won't work because you don't actually have enough tokens, and it's great to get the actual current balance. The next thing is to be able to get all the files. So I reference the SVG folder. From here, I'm going to get that directory and then spit out all the files, right? Just themselves, just get the SVG files and say, okay, I'm only getting these SVG files. So this is just a filter to be able to make sure I'm only using SVG files as opposed to any other files to be able to upload. The next step is to fund the node. So what I need to do to fund a node is I need to get the actual file size of each one of the graphics. And from there, it'll get a calculation to be able to calculate how much Matic I actually need to be able to fund the node to be able to do the upload. So note here, I have all the paths from the SVG files. I join them and then I increment this file size on this one size variable. And from there, I'm going to output that and say, hey, this was the actual price. I'm going to go get price from bundler of that actual file size to number. I'm going to divide it from the currency in terms of the number of decimal places. From there, I should get what my price is for this transaction of all 4 graphics. The next thing is the actual funding. So now that I know the amount, I'm going to fund it. So this is like prepaying ahead of time to be able to process the transaction. So I'm going to say here, this is the fund amount to be parsed. So notice that I'm taking the price as a big number, and then I'm multiplying it by the currency config from bundler itself. So this will get at the amount that the actual format that's needed to be able to fund bundler of the actual Matic that needs to be sent. So here I'm just going to output what that looks like as a string, and then actually process the funding to be able to send it to the network or that node. After that, it's going to convert that balance and then just say, hey, this is the converted balance that was sent essentially as an output. Lastly is the uploading aspect. So what I'm going to do is take all the SVG files, we reference those names going in the directory as a for loop, and then I'm going to wait for them to upload, get the Arrowweave transaction ID, and you'll notice that it's prefixed by this constant, which is arrowweave.net. From there, you're able to then see all the URLs of all the graphics that have been uploaded. So I'm going to process this now to be able to do the upload. So to run this, I'm just going to go /node.bin tsnode upload Arrowweave files. And from there, we should see it fund and go through the upload process and output the console logs for each step. And there we go. We've successfully uploaded all 4 images. So if we take one of these URLs and put it in our browser, it's that transaction here, we'll see that it shows the actual transaction data, and the SVG is coming back with the full graphic of the SVG and the animation with it as well. Now I'm going to make this a little bit easier myself in terms of uploading these files. So next time I do try to do something like that, I'll just modify my package.json file and just add upload files. The next thing I need to do is, because I actually have all these URLs, I need a manifest, or essentially JSON files that follow the OpenSea standard of what that JSON looks like in terms of the name, the description, and essentially just as it increments as it relates to every token ID. So in NFTs, you imagine token IDs can be 0, 1, 2, 3, whatever number, and we're trying to essentially have it increment within one specific folder. Now you'll notice that I've uploaded these files individually, so they have unique addresses for each image. What I'm going to try to do is have a folder that just references JSON files, and in those JSON files reference those graphics from Arrowweave so that it's able to pick up from NFT readers like OpenSea for that matter. Now I will preface that OpenSea isn't supporting zkEVM just yet, but we'll show an example of how to be able to see your NFTs. So what I'm going to do is create a new folder called manifest. So in my manifest folder, I'm going to create a 1.json file. From there, I'm going to paste a format that has been specified from OpenSea to be able to actually parse these NFTs in a specific way. So the attributes are description, image, the name, and I give it Blade of Souls in this case, and then giving it an attribute of a trait damage of 12. Okay. So what I'm going to do is find the sword image. I'm going to assume it's this one and paste it here under the image. And for the descriptions, I'm going to use ChatGPT to be able to come up with the description, because I'm too lazy to be able to think of or imagine some sort of really, really nice description of this particular item. So in ChatGPT, I'm just going to go create a mythical 1 to 2 sentence description for an item called Blade of Souls. Perfect. So I have my description. All I'm going to do is copy that and paste that into the description here. So now that we have the full format, and what I'm going to do now is create JSON 1, 2, 3, 4 as it relates to each one of these graphics, so that each one has their own specific description. Now you might have noticed that the description changed and the URL might have changed a little bit, and that's just for me to save time to get to the next step. One other aspect that I'll add to this is the contract JSON, or the metadata specifically for the contract, that we're going to utilize so that OpenSea can understand it in terms of a collection. So for that, I'm going to create a contract.json file. And in it, all I'm going to do is paste in the name and the description of the mythical cards so that everybody knows what this is. So when it picks it up on some NFT readers, it's able to understand specifically the contract URI. So the next step I need to do is upload all these files to a single folder on Arrowweave so that I can reference it as 1.json, 2.json as a appended value at the end of that URL. So to do that, I'm going to create a new file in the upload directory called rweave folder.ts. In it, I'm going to paste all the code that I had for the folder. You can see that I'm referencing the bundler client, the FS and the path, and the environment variables to be able to pull in. Everything is the same in terms of the bundler network, etc. Everything that we saw in terms of the files. The only difference is we're going to upload a specific folder. And you'll see that the folder path is set to the manifest, which is here. And then it's just going to check if the folder exists. And then from there, it's going to upload the folder. That's what's different. And say, hey, the number of items to upload at once, you can increase this. No need to do the indexing or keep delete for that matter. I'm just going to upload the folder path and then see that final value as the transaction come at the end so that I'm able to reference it. And just to make it a lot easier on myself again, I'm going to open my package.json file and create a new command called upload folder. So all I need to do is pnpm upload folder, or npm run upload folder. Folder exists. And here we'll see that I don't have enough funds. So this is a great use case of being able to make sure that we fund it correctly. So if I went to my rweave folder and notice that there's no funding because I don't know what the sizes are. So what I could do is leverage the rweave files in that sense, and be able to go through the funding process too. So here I can get the files and then from there fund them again. So I'm going to copy this, go to my rweave folder. What I'm going to do is make sure that that folder exists. After that is I want to get all the files in that folder. So the folder path is manifest. I want to make sure that I get any files that are JSON files. Folder path manifest to be able to make sure everything is working, and output the JSON files. From there, I'm going to get all the sizes and then fund the node itself. So here I'm going to paste get the total size. So I'm going to replace this with the JSON files and make sure that it is set to manifest. It'll get all the sizes from there. And then what I'll do is convert balance. So we'll need to import that as well. So what we need to do is make sure that we get the current balance, and we're just going to paste that at the very top here to be able to get the current balance for things. And then from there, I'm going to also import the big number because we'll need this to do the conversion for what needs to be funded. Now that that's set, we get the manifest part, which we'll paste here. It'll go through all the files. It'll fund the node. From there, it will process or get the amount for the size and then actually process the funding for that specific node, and then go through the process of uploading that folder. So let's try this again. I'm just going to go npm run upload folder. It'll go through the process of reading the manifest.json file, making sure that the folder actually exists, and then we should see the final transaction of the folder uploaded directly to rweave. So if we pasted that URL here and appended one.json to it, we should see our original JSON file, which references also the graphic. And we should that number should be able to increment up to 4, as well as our contract.json, which should be the metadata for our contract specifically as well. Now, what I'm going to do with this specific URL is add it to my environment variable as a base URL. This will be used for passing to our contract to say, hey, these are all the files as a base folder that we should reference. Now you'll notice I did append a / at the end of this. This is so that we don't have to add that in the contract itself, and we can reference the file names as opposed to the /. Next up is I want to be able to create our contract, but to do that, I have a package.json and a tsconfig already configured, and I need to initiate hardhat with it. So what I'm going to do is going to remove those and then start the process for hardhat. I'm going to choose TypeScript, choose that particular directory, and go to install all the dependencies. Once that's done, what I'm going to do is change my lock.json file or lock.solidity file to rename it as mythiccards.sol. And the other thing is I'm going to remove the test folder because we don't have time to go over all the tests here. So I'm just going to remove that folder and go start coding in the Solidity file. So because I deleted my package.json, I need to reinstall all those other dependencies that I had before and install one more, which is the OpenZeppelin contract. So I'm going to install the big number OpenZeppelin contract as well as the dev dependencies of the types. Once that's done, I'm going to open my Mythic Cards contract, delete everything in there, and I'm going to paste the contract code that I had set up prior. So you can see this again on my Medium article for the actual code or the Git repository, which I'll share at the end. So I'm just taking advantage of the ERC1155, burnable, supply, pausable, ownable, and converting to strings. And we'll need this specifically for the contract URL or the base URL that we're passing for the different token. We're also taking advantage of a random number. You'll notice that because I'm deploying to zkEVM, VRF is not necessarily supported yet, but I imagine it's going to be coming relatively soon. So you'll see here that the constructor, I'm passing a new URI. This is our base URL that we set up in our environment variables that we're going to be passing through. So that'll be the base for our contract.json and our 1.234.json files for our NFTs. Set URLs if we want to update that. Pause is to be able to obviously pause the transactions and unpause. And then generate random numbers. So this is a new function to be able to create random numbers. So what it does is I'll call this and apply to the public variable up here to set a new random variable. So where I'm going to be taking advantage of that is in the mint function, where I can specify the amount of NFTs I want minted. It'll go through a for loop, and each time it'll generate a random number between just a random number, an integer for that matter. And then what I'm going to do is apply some logic to it in the sense where if it is divisible by 4, so in other words, modulus 4, I'm going to say, hey, the range is essentially between 1 and 4. So then make sure that I get a number range within that set or that constraint. I'm also passing it to the mint function, which is the sender address, the token ID, which is that random number, and the amount, which is 1, because I'm going to iterate through each one of these one at a time, and the data, which I'm going to set to blank, which we don't necessarily need to pass. Additionally, we have these before transfer tokens. These are just default that are just implemented. And then we have the function URI, which is where our NFT is going to be read. We'll see here that we've cast a string over top of it. We're going to ABI encode, and then we're going to pass it from essentially the master contract, from the 1155, passing in the token URI, which should get our base URI from there, and then pass in the token ID as a string and .json. So that should come back as whatever our env file for the base URL /123.json. And then the last thing is we have our contract URI, which is standard function for being able to read the metadata for our contract. And you'll notice here I'm passing a token ID of 0 because it doesn't matter. I'm just getting the base URI, and then I'm appending contract.json. So if we go through this, we're going to now configure this for Hardhat to be able to deploy to zkEVM. So here in my scripts deploy file, what I'm going to do is just remove everything that's in there and paste in our new code. You'll notice I'm importing ethers, my env config file, so that it loads in the environment variables. I'm going to get the contract factory, essentially the contract name. So that's something that I'm going to need to change in my .env file here. I'm going to set contract name is equal to, and it's the name of the contract itself. So zk Mythic Cards, I'll paste that here. Then what it's going to do is once it's deployed, it's going to output the contract address of where it has been deployed. So relatively simple in terms of our deploy script, but we need to configure our Hardhat config to be able to specify which network we're deploying to. So next I'm going to go to my Hardhat config. I'm going to remove everything that's here. And then what I'm going to do is you'll notice that I am importing my env file again. I'm setting some optimizations on specifically Solidity for the number of runs. And then I'm going to set my zkEVM testnet to process the RPC URL and the wallet private key. So that's the next thing I need to add to my .env file right here as RPC public zkEVM testnet. So we should have everything set up for our Hardhat config. And the next step is to deploy the actual script. Now, in order to make sure that I have zkEVM as a network as well as the bridged amount, a good way to figure this out or get the value of Gurley essentially bridged over to zkEVM, I need to go to wallet.polygon.technology, switch over to zkEVM, make sure that I'm set to testnet, and go to bridge. What that's going to do is prompt me to connect my wallet. I'll be brought to the dashboard, and we should see that here on specifically Polygon, if I switch this over to zkEVM because testnet that I'm already set up with, you'll see that I have some amount that's already been bridged. Now, if I didn't have any, I could bridge it over by going to Gurley essentially, and then start the process of bridging some over. Note that when you do bridge it, it can take up to 30 minutes. So what it'll do is it'll lock up those funds, and then once it's complete, you'll switch over to zkEVM and then claim that transaction so that it's fully bridged over from Gurley to zkEVM testnet. It's worth noting that you can also switch this back and forth, convert zkEVM testnet to Gurley, back and forth. Again, the amount is 1-for-1 in terms of what it's being transferred. So I already have this, so I don't need to worry. I already have zkEVM tokens to be able to deploy the contract. So to deploy it, I'm just going to go npx hardhat run scripts deploy.ts -- network zkEVM testnet. And we can see that it have been successfully deployed to this specific address. Now, if we went to testnet -zkEVM Polygon scan, we can actually paste that contract address and we should see it deployed just a minute ago. Now, there are some things still being worked on. This is really early in terms of contract verification. So if we went over to explore.public.zkEVM-testnet.net, we should be able to see our contract. And I actually had deployed this previously, so this should already be verified. But if it wasn't verified, you can go through the process of doing the standard input JSON to do the verification process. So now that I have the code actually verified, I'm able to interact with it through the Block Explorer. So I'm going to go to write contract. Here it's going to prompt me to connect. As I'm connected, I'm going to scroll down to mint and input 5 NFTs that I'd like to mint. I'll also need to make sure that I'm set to Polygon zkEVM testnet. And then what I'm going to do is go right. It's going to prompt me for the transaction. Once a success, I should be able to see those different transactions. So I'm going to open this up in a Block Explorer. So here we're going to mint and view on Block Explorer, which will pull up Polygon scan. You'll see I've minted 5 different tokens with 1, 2, 3, 2, 3 in terms of random numbers. So we know that ID 1, 2, 3, and 2 are essentially all minted. So if I go back to our contract, go under read contract, and then I go to URI, token query, we'll see that the URL comes back, which is our 1.json file, which references the image, and we can see that our NFT has been fully minted with that specific NFT. Now we can also see that the balance of the specific address and the ID. So if we took my address and we put in 1, we'll see that I have a balance of 1. If I put in ID 2, I should see that I have 2 of those as well. If I have any of 4, I should show 0. So showing that I actually have 2 of a specific item and 1 of a specific item that I actually own for those. So this is great because, again, as we're doing, if you're doing NFTs for gaming, you should be able to have multiple items, which might be a set standard, and they could apply to multiple players. Now, if you did want to go through the verification process, I do have the step-by-step here in the article. So you should be able to copy the standard JSON input and then paste that essentially to the verify and publish and go through the entire process. So I definitely recommend checking the article to go through that entire process as well. Now I will say that zkEVM is not fully supported on OpenSea just yet, but as far as goes, this is an example that I deployed to Mumbai, and we're able to see that it has multiple owners in terms of 2 or 7, and you can see the rotation of that graphic fully minted. So this is essentially what it would look like in an NFT marketplace, pulling that data from the URI data from the 1155. And if you want to see the full code, go to codingwithmanny-zkEVM-ERC1155. You'll see the entire walkthrough as well of all the steps, how to set this up, how to go through the process of the upload process and see the different graphics. So definitely check out this repo. This should be an easy way to get you up and started deploying to a zkEVM with ERC1155. And lastly, check out the ultimate ERC1155 Mythic Card NFT contract walkthrough on Polygon zkEVM article. This will go through step-by-step, really hand-holding you for each step of the way, what button to press, what code to enter. This is a great resource to be able to follow along with this video. That said, that's how to deploy an ERC1155 NFT collection on Polygon zkEVM. If you like this, make sure to like and subscribe and wait for my next video.